So I'm going to teach you all of the ways that we can solve systems of equations. Okay, usually the math books will teach you how to do it by graphing. Then they'll teach you how to do it by substitution. Then they'll teach you how to do it by elimination. I want to give you a toolbox full of tools to know how to do it depending on which is the best situation. So a system of equations is basically two or more lines that are meeting at the same point. So, for example, if a missile were to come from North Korea, as a matter of fact, to the California coast, the missile that would intercept it is going to hit it at some point. Okay, that point is where those two trajectories hit. So when we're talking about it in a two-dimensional plane, we're looking at two lines and where they hit each other, okay? Now you can solve that by graphing, but usually it's not super neat to do it by graphing. It's going to go through a hack somewhere or whatever. It's going to be hard to know exactly where that point is, where the two graphs come together. So what you're going to want to do is learn how to do it algebraically. So we're going to take these two equations and we're going to solve them all three ways. So y equals negative 2x minus 3 and y equals 2x plus 5. Okay, so we're going to do graphically by graphing. I'm going to write by graphing. Elimination. And substitution. So if we were to graph these two lines, this first line would start at negative 3, and we would go down to and over 1. And there would be our line, which we've already learned how to do. Okay? Because this is 2 over 1, so our slope is rise over run. We'll go down 2 and over 1. For this equation, we're going to start at positive 5, and we're going to go up 2 and over 1. Well, obviously I didn't draw my graph good enough. I think this one's a little bit off. So let me clean that up. Because I already know where these two meet. Let me fix that. And we're going down to negative 3. And we're making a point because that's where we begin. And then we're going to go down to 1, 2, over 1. And it's more like that. So you need to make sure that you're extending your lines, okay? So if that was on graph paper, we would be able to tell right away where that is. So let's look at it using elimination. We're going to solve it algebraically. So by doing elimination, I'm going to take both the equations, negative 2x minus 3, y equals 2x plus 5, and I'm going to add the two equations together, okay? So I'm going to add them together, and I'm going to get 2y equals negative 2x and positive 2x goes away, and then I get 2. Negative 3 plus 5 is 2. Then I divide by 2, and I see that y equals 1, which is right here, right? Y equals 1. And then if we try the other equation, then we're going to plug in y. This y needs to get plugged into either of the original equations so we can solve for x. So if y equals 1, I'm going to do y equals, let's do negative 2x minus 3. I'm going to plug 1 in there. So I'm going to get 1 equals negative 2x minus 3. Add 3 to both sides. And I'll get 4 equals negative 2x. Divide by 2. And I get 2, negative 2 equals x. Okay, so if negative 2 equals x and y equals 1, my solution is going to be negative 2, 1. If we go back to the original equation, we can see that the negative 2 right here and the 1 are exactly where the graph met. Okay? So now we're going to try solving by substitution. Well, if we look here, we have y is equal to negative 2x minus 3, and y is equal to 2x plus 5. So let me write that. 2x minus 3, and y equals 2x plus 5. With substitution, I can say, oh, well, if y is equal to this, I can plug it in there. Because y equals 2x plus 5, I can plug it in there. So I'm going to say 2x plus 5, which is y, is equal to negative 2x plus 3. I'm going to get all my x's on one side, solve for x. So I get 4x plus 5 equals 3. Continuing to isolate x, I get 4x equals negative 2. So actually this is a minus 3. I wrote it down wrong. 2x minus 3. This is a minus 3. So this is a negative 8. Divide by 4. And I get x equals negative 2, which is what I got there. So using substitution, we end up getting the same answers. Once again, I can plug in negative 2 into one of the equations like I did in the elimination, and I'll come up with 1. Since x is negative 2, if I plug it in, I'll come up with 1 like I do here. Actually, here. Okay? So we are going to go ahead and try some so you can get some practice.